Hello, welcome back to IBM TechCon. This is day 3. It's our final layup as we approaching our final sessions. But thank you for coming back, and we are continuing the conversation on HashiCorp. So IBM is really excited to be welcoming HashiCorp. And our last session, we focused on the infrastructure. And for this one, we have two senior technical product marketing managers, David Mills and Van Fan, and they'll be talking about the security lifecycle management piece of HashiCorp. So make sure that you ask questions, put your questions in the chat. We'll make sure we get them answered. So with that, I'm just going to hand it off to David and let them start to fill you in on what HashiCorp has to offer.
Thanks, Peggy. Hello, everybody. Welcome to Security Lifecycle Management with Vault, Boundary, and Beyond. Like Peggy mentioned, my name's David Mills, and I'll be co-presenting today with Van Fan. We're both Senior Technical Product Marketing Managers with HashiCorp, now an IBM company. And yes, we are excited to be part of the IBM family and looking forward to sharing our products with you today. So to set the context before we dive into the products, I'd like to quickly cover what we mean by security lifecycle management and how our products support it. Security lifecycle management to us is really all about being able to inspect, protect, and govern your cloud and on-premise environments. To do this, you need to be able to inspect things like infrastructure and applications for risks like unsecure secrets, be able to remediate them. You also need to configure policies and mechanisms to protect against new or ongoing risks. And finally, you need to govern the sensitive elements of all environments in an ongoing, automated way by enforcing things like centralized secrets management and identity-based access controls for people, machines, and services. The products Van and I will talk about today help support this security lifecycle management. Starting at a high level, let's take a look at how these products work together. First, Vault Radar focuses on secret scanning and remediation. You can scan a wide variety of data sources, including developer tools, CI/CD platforms, and collaboration tools to discover exposed secrets. You'll get prioritized risks and help remediating them, which could include importing them into Vault if necessary. Vault is our platform for centralized secrets management. You can securely store secrets and control access to them. These secrets include things like certificates, access tokens, dynamic and static credentials, and keys. So Vault also enables you to create and manage policies that you use to govern access and the usage of those secrets as well. Boundary provides secure access for people who need to connect to critical infrastructure with least privileged secure remote access. Boundary also works with Vault, where you can store your credentials and then inject or dynamically create credentials for developer sessions without the user seeing them. Boundary provides an easy user experience for developers while also providing identity-based access. With Boundary, developers can use their own workflows and tools. And finally, Console is a service networking solution that enables teams to manage secure network connectivity between services and across on-prem and multi-cloud environments and runtimes. You can also leverage Vault-backed credentials with Console. Many of you are probably familiar with Terraform. The security lifecycle portfolio also works with our infrastructure products, and Terraform is one of them. The most advanced and controlled operations leverage Terraform infrastructure as code to deploy our SLM products at scale. So now let's take a look at how Vault and Boundary specifically can help improve security lifecycle management and mitigate common risks. First, we'll take a look at how an organization can discover unmanaged static secrets and begin to remediate them with Vault Radar. Next, we'll talk about how to start securely and centrally managing secrets within Vault so they're not spread out across environments. Then we'll see how to further reduce risks by introducing the use of dynamic secrets using Vault. And finally, we'll look at how Boundary can help streamline the whole workflow for end users to more easily and securely access both credentials and their important infrastructure resources. So let's start with finding those unmanaged secrets and sensitive data that everybody has out in the wild. Vault Radar enables you to scan your existing estate for unsecure secrets so you can investigate, triage, take action, and then remediate those risks. After scanning repositories and environments, you can quickly see if you have any critical issues in the overhead dashboard. Then you drill down to investigate and remediate them. Vault Radar supports real-time discovery of secrets. One of this example of this capability is the ability to configure webhooks on your code server so that when developers commit code, the webhook will notify Vault Radar, which immediately runs scans to discover whether new secrets have been committed. Radar supports scanning prior to your CI/CD pipeline with pre-commit and pre-receive webhooks, and it also scans pull request checks and tip of branch scans in your CI/CD pipeline. Tools like Jira integrate and they enable automatic creation of records when secrets are discovered. So that enables auditing of incidents and triage of backlog items. Once exposed secrets are identified, teams need to focus their remediation resources on the ones that pose the highest risk. However, security and ops teams are often faced with things like false positives. Because they get so many results from whatever scanning tool they're using, it's hard to sift through and find the most important ones to start working on first. Also, they have problems with slow internal response through ticketed workflows and using a lot of manual processes. To address these issues, Radar leverages prioritization data points to increase accuracy and prioritize things. For instance, activeness. When Radar finds a credential, it can call out to the associated service to check if the secret's still active, such as Cloud AWS or Azure credentials or GitHub personal access tokens. High entropy. Radar evaluates the content for random or complex strings, which often indicates API keys or user access tokens. In terms of version control, Radar can even determine if the finding is in the current version of a file or if it's hidden away in the commit history. Some examples of how the severity and risk definitions are determined and applied are if something is found and it's labeled critical by Radar, the secret's active, and additionally the secret is in the latest version of content within a resource or secret manager. If it's labeled as high, the secret's active, but the secret's not in the latest version of content within a resource. Also, maybe the activeness can't be determined, but it's in the latest version of a secret manager. And then if you have medium, it's none of the other conditions, and the severity set to medium by default. There are also ways to customize those alerts so that they fit your use cases. But Radar is doing all of this investigating and post-scan checks so that you can get to the most critical issues and deal with them first and weed out the noise. There are three ways to use Vault Radar, or three mechanisms for scanning. The first is the SaaS platform itself. So HCP Vault Radar, you can scan data sources using the platform. There is also a CLI tool, so you can run this on premises without HCP integration. So some customers are sensitive to scanning environments and they don't want to do it from a cloud platform. They can run this tool on premises, gather those results, and then upload them later. The newest capability is actually a hybrid agent. This allows for on-premise and self-managed scanning from a command line interface like the command line tool does, but it's also integrated into the HCP portal, and you can scan cloud-based or on-premise-based data sources with the new hybrid agent. There's also a currently long and growing list of supported data sources that Vault Radar can scan. This includes Vault. So you can correlate results of your scan with secrets that are currently stored in whatever vaults you're running, HashiCorp's Vault product, and then you can find out whether those secrets being managed in Vault have been mishandled and are now exposed. So it will also handle that correlation and then allow you to triage that and figure out what you need to do next. As I mentioned, Radar integrates with common developer workflow tools to facilitate that detection and remediate things on an ongoing basis. These integrations support a robust set of workflows via ticketing and alerting solutions. And this is really meeting organizations where they already are by leveraging those common tools that are already being used by engineering and development teams and allowing them to have that flow in terms of security incident response. This is a simple flow that you see on this slide here, and it works something like Radar scans and finds an alert or finds a secret, and then it actually pops up an alert in Slack. And whoever's in that Slack channel, it could be the administrator, the person responsible for that environment, they get notified that there's an unmanaged secret or secrets that are detected. The alerts include details on where and what type of secret was found, plus there are links in that message that go directly to the file and the secret that was found. So from getting that alert in Slack, you can click that link and see the secret. After investigating that, there's also a link in there that allows you to click on documentation for remediation steps for that particular kind of secret or that situation. And then the administrator can take it from there. If the secret needs to be put into Vault and removed from the source and then rotated in Vault, and then they can take those next steps. So with that, let's look at a quick demo of how that basically end-to-end workflow works from discovering a secret with Vault Radar to actually copying it into Vault. So in the overview pane, I can quickly see any incidents I have after scanning my monitor repos. I've got a high severity incident in my TF files repo, so I click the link to the source and see that there are AWS secrets and access keys in this file. So there's that link that I can click and go right to the source. Next, I can click on a link that takes me to remediation steps that I can take to resolve that issue, and that's also right from that alert. If the remediation steps require it, I can also copy secrets over into Vault so they can be securely stored, accessed, and managed. And here I'm going to click to store that secret, and then I've got a path to that secrets engine and the secret path where I want to copy it in Vault. And so I'm going to enter my secret key in there, and I'm going to confirm it. So now when I jump over to Vault, I'll be able to see that secret mount or secret engine, and I can click on it and I can see that my secret was copied over from Vault Radar. So pretty powerful capability from discovery to being able to put that secret in a safe place. And then the secret that was found in the wild can be revoked, deleted, or whatever you need to do with it next. So now that we've detected these unmanaged secrets, it's obvious there are more different locations in which you store secrets. The more chance you have of them leaking out. The simplest first step is to move your static credentials into Vault's KV secrets engine, like I did just there in that demo, where those secrets are secure, they're limited to specific users, roles, or groups. Now let's take a closer look at how Vault works and how some of those other secrets engines work as well. So first of all, you can see Vault here. There's secrets engines there for things like key management, cert management, the static KV secrets management engine that's in there, even encryption capabilities like transit encryption and that sort of thing. So that all lives securely inside of Vault. Now, how this works is a client's going to provide their credentials to Vault requesting access to Vault. Then Vault is going to use authentication plugins to validate the client against the appropriate trusted third-party resource. It might be GitHub, LDAP, CSP, or other providers. Once that client is authenticated, Vault will grant access to secrets, keys, and what's inside of Vault. And it's doing this by issuing a token that is tied to policies that get associated with that client's identity. And as you can see, there's a central policy control that's also living inside of Vault. The client can then use that token granted by Vault to securely access whatever resources they have access to. And I'm just going to stop for a minute to say, when I'm talking about clients, this can be human, this can be machines, because it could be an app that's reaching out to Vault and requesting secrets that it needs to access a backend database. So that's what we mean when we're talking about clients. So very broad use there. So now the client is going to use their policy-based access to retrieve secrets or perform what other operations they need to perform with Vault. These static secrets can be centrally managed and automatically synced to destination resources. So this is an interesting feature where if you have developers in a workflow and they're using their tools, they may have AWS Secret Manager where the secrets get locally stored and automatically grabbed when they're doing their runs. You can still centrally manage those secrets within Vault and then be able to sync them. So you're managing them in Vault, sync them to the endpoints securely where they're being used in whatever workflow they're being used without interrupting that workflow. And then Vault also keeps centralized logs, detailed logs that are retained for monitoring and compliance purposes. It also supports an API where you can plug in external resources or external tools like Datadog or Splunk when you want to dashboard and pull out and do further analysis on the logs that are contained within Vault. So to recap, Vault enables secure, scalable access to secrets and sensitive data across multi-cloud and hybrid estates. You authenticate and validate using plugins for third-party providers. You can enforce policy-based access with a central policy store. And then you also gain visibility and control with audit logging and third-party tools integration. You can configure Vault for disaster recovery, high availability, and performance replication. So this is all about how do you configure Vault and the architecture that's appropriate for your environment and your purposes. Vault also automates workflows for secrets creation, management, plus data protection and encryption. So you can use, you have access to 40 plus secrets engines to automate management of secrets. That includes things like certificates, keys, and tokens. When I say secrets, it's an all-inclusive category. There are also secrets engines that support data protection, like transit encryption, tokenization, and more types of encryption. And then you also can centralize your static secrets management, supporting native developer workflows with that secret sync that we were just talking about. So now let's take a look at secrets management and go to the next level of security and reduce risk even further. We've got our static secrets centralized in Vault. We're using the KV secret engine to manage them. So let's talk about dynamic secrets and how you can use Vault to create and automate more dynamic secrets, and maybe why you'd want to do that. A lot of organizations have a large number of static secrets in their environments, but for some use cases, static secrets just aren't ideal. For instance, if you're running DevOps workflows, you want to be able to grab secrets exactly when you need them, and you want them to be revoked as soon as they're not needed anymore. You don't want people hard coding them or putting static secrets in code because it's the easy thing to do. That's a great case for dynamic secrets. So if you have all the static secrets lying around, there's a high risk of breach, and they get exposed, they get leaked, they get stolen. It happens all the time. There's lots of data breaches every year that involve unsecured credentials and a bad actor. So let's see how we can use dynamic secrets with Vault. They're generated on demand. They don't exist until they're needed. There's less risk of someone stealing them or another client using the credentials. With dynamic secrets, you generate them just in time. They can also be set with customized time to live timelines so that they expire or they get revoked automatically, but without administrative interaction. There's a leasing mechanism for dynamic secrets, and that's a way that you can know which secrets a client has because they're unique to each client that requests those secrets. There's no need to rotate the credentials because Vault simply generates a new credential the next time you need one. And unlike static secrets, unique credentials are created per client, which makes it much easier to do forensics and understand the source of compromise. And by avoiding sharing those credentials, we remove the ambiguity of access as well. Vault has a lot of different secrets engines that support dynamic secrets. You can see in the database space, there are a lot of different databases that are supported there. The major cloud service providers, the secrets engines for those cloud providers within Vault support dynamic secrets, and we're going to look at AWS credentials here in a moment. In terms of LDAP, the LDAP secrets engines support a lot of directory resources that are plugins and can also generate dynamic credentials there. In terms of certificates, Vault supports SSH and PKI certificates, management with those secrets engines, and they can also be dynamically generated and managed as well. So with that, let's go ahead and look at a demonstration of dynamic credentials with Vault. So with this demo, I've configured Terraform to create S3 buckets, and I want to use automatically generated dynamic AWS credentials and offload the lifecycle management of credentials to Vault. So I'm going to walk through two different modes of working with AWS credentials in Vault. The first mode is to manually create credentials and then use them as TF variables or Terraform variables. That demonstrates these credentials can be generated and used in whatever platform you need. The second mode I'm going to show is to dynamically generate credentials, allowing you to generate a new credential each time you do a Terraform run. And you can see here, I already have the AWS secrets engine configured, and that's just a matter of enabling it. Now, it's configured with an IAM user access key and secret, which gives Vault the permissions to generate new AWS credentials. Alternatively, you can configure and use workload identity federation to establish trust between Vault and AWS to avoid using static credentials. Within the secrets engine mount, you can create one or multiple roles which match to their own IAM policy defining what permissions that user will have in AWS. So we can then generate credentials against these roles. I just have this demo role right now, and we can issue 4 types of AWS credentials depending on your preference and requirements. IAM user roles, assumed roles, federation token, or session token. And I'm just going to use the assumed role in this case. Then I'm going to go ahead and change the TTL value to 900 seconds, aka 15 minutes, and then click on generate to create those new credentials. And so they just get created as soon as I click on the button. And here you see that I've got my credentials, I've got my access key, I've got my secret key, and I can copy those over. So here I have 3 variables that start with the prefix AWS in my Terraform variables. So I'll need to update each one of them with the values that I just generated in Vault. So just a little patience as I manually copy and paste these over, and then you're going to see how this works. And then once I've pasted them in there, the last one to go here, I'm going to save that, and then I'm going to kick off a new run. Click start. And now what I'm looking for is a null resource. And so as the plan is running here, I'm going to go ahead and expand that null resource. And I can see that the caller user ID changes. This field represents the user who's initiating the action on AWS. It changes because with each run, Terraform requests a new credential from Vault for execution. And you can see the old and the new credentials there. So to configure this dynamic capability on the Terraform side, we're going to reference code that's in Terraform. And I'm going over here to a workspace that is configured to do that. This is a Terraform file that I have that is referencing code for the secrets engine, referencing the role. It's going to use the AWS IAM role that I generated from Vault, or that gets generated from Vault. Now let's go back in and I'll show you the key variable for this automated run. And it's already configured to talk to AWS or talk to Vault in the AWS secrets engine. You can automatically generate these variables and then enter those in, and it's got the role name right there. So this is the variable that's important for this automated run, and that's going to tell Terraform where to grab those credentials. So I'm going to kick off a run again using this different method. And now I'm going to look at my null resource, and I see new credentials were automatically generated. So this demonstrates we can configure Terraform and Vault to generate new credentials during execution that are known only to Terraform and Vault. So you can see it's easy to configure Terraform and Vault to generate these new credentials during execution. The key benefits of this are you can automatically generate and retrieve secrets from Vault on demand. You're going to use short TTLs and automatic revocation procedures to reduce the risk of secrets exposure. And then implementing the lifecycle automation of dynamic secrets lowers that overall operational cost and risk of downtime and breach. So with that, I'm going to go ahead and hand it over to Van Fan to get into the details of where Boundary fits in and help secure human access to sensitive resources and organizations. Van, off to you.
Awesome. Thank you, David, for that. So hello, everyone. Before I get into it, we do have a quick poll. It's basically just one question that's going to pop up on your screen. And we really want to know, who in your organization, what type of persona or role is usually the ones that are deriving the ownership and the deployment of a privileged access management tool to enforce access and secure access into your environment. So just take a couple of seconds there to answer that, and then we'll get started on my section in a couple of seconds. So give it about 10 seconds, and then I'll jump right in. Okay, so hopefully that's enough time for you to answer that quick poll, and we'll just get started now. So as David went through the whole maturity and journey of a customer as they adopt the various features of Vault and how that gradually lowers the overall risk, now let's talk about how developers and other end users can use the credentials that were provided by Vault to be able to access the infrastructure, and also how Boundary can improve that from a security perspective, lower the overall risk even further, but at the same time really helps simplify and streamline that whole end user workflow, the whole end user experience when they're trying to connect to a private resource within their network and within their environment. So traditionally speaking, right, anytime you're adding something that is more secure, it often comes at the cost of adding more complexity to the end user experience, and vice versa as well, right? So, for example, using a traditional VPN to access infrastructure resources may be fairly simple. You've done it for many years. I've done it for many years as well. But there are risks that are involved with VPNs, right? And vice versa. If you're using something more secure, like a privileged access management tool, a PAM solution, many times it involves an increased complexity for both the end user and the administrator, even though it makes things more secure. So furthermore, many customers and many companies are converging on the fact that you're using a multi-cloud strategy, which makes it even more complex for end users to access a lot of these ephemeral workloads and ephemeral resources across different environments, across different clouds, right? So those are kind of some challenges that a lot of organizations are facing. So that's kind of what Boundary really was built for, right? At its foundational core, Boundary provides end users with simple and secure access to their infrastructure resources. So those resources could include Linux hosts, Windows hosts, Windows servers, databases, private web applications, Kubernetes clusters, etc. Right? So Boundary enforces least privilege access for these users to access those type of resources and those targets, but only give them access to the ones that they've been authorized to connect to. So no more and no less. Boundary also handles credentials on the end user's behalf, which is more secure because it's ensuring that those credentials can be properly rotated by a single team or single admin, and also reduces the burden on the end users themselves having to store and retrieve credentials every time they want to access some type of resource within the environment. Secondly, what good is a platform if nobody uses it, right? One of Boundary's key objectives is to make things simpler for the end user. The goal is really to allow users to continue using their existing day-to-day experiences, their day-to-day workflows, and their day-to-day tools. We don't want the end users to have to learn new tools and learn new processes to connect to the same resources that has always been existing in their environment. So with Boundary, they get a VPN-like experience, right? Something they're very used to already, and they can use the same existing tools. And the only thing they really need to do is log on to Boundary. And so, like I said, it's just like a VPN, except it's more secure, and it's also more simpler end-to-end from a user connecting to their target resource. Lastly, Boundary helps organizations really meet compliance and regulatory requirements as well, with extensive audit logging, streaming capabilities to event logging platforms, and SSH session recordings that give detailed information about user activity, where you can play back videos of what every single user has done in a SSH session. So we'll see a demo of that in a bit here. So these tools, well, session recording specifically, it's valuable for compliance, but it's also valuable for things like, if there was a breach, using the playback to facilitate remediation and an analysis of a specific breach, right? So those are kind of the overall things that Boundary brings to the table from a high level. But let's kind of walk through a little bit more of a specific comparison of why Boundary is helpful from a security perspective and also from a simplicity perspective to that end user. So we'll just walk through a scenario where an end user would connect to, a resource within their environment. And again, traditionally speaking, a lot of customers are used to using VPN and a jump host, and we'll compare and contrast that to how Boundary does this for them and see what the differences are, right? So as an end user here, you can see that if I want to log in to connect to one of my resources, let's say I want to connect to this Linux host over here, say it's a Red Hat host, we will have this end user. The first step they would do is log on to their VPN, right? We've all done it before. Pretty simple, pretty straightforward. However, from a security perspective, once they log on, they sort of have unfettered access to anything in that network, or at least in that subnet, right? They can roam around. Whether they have access into those credentials to log on or not may be a different story, but they still have the ability to kind of roam around, feel out the network, and ping different IPs and see what's out there, right? So that's one security concern, because least privileged access is not enforced. The second thing they would do is, let's say they want to connect to that Linux host. They'd have to know the location of it, right? So maybe they know it off the top of their head, but likely they have a lot of resources, a lot of systems that are connecting to day to day. And so, maybe they're probably tracking it somewhere. It could be something like a spreadsheet, or it could be like some type of web console that they'd have to go consult and find out the location of that resource, right? So then they have to go to this other tool. That's the second step. The third step is they'd have to grab the credentials. So in this case, let's say they are using Vault, right? Instead of having a password written down or something, let's say they are doing something that is secure, like using Vault and leveraging all the security capabilities that David mentioned, which is to grab dynamic credentials from Vault. So great, we're great from a security perspective if they are using Vault, but it does require them to take this extra step to go to Vault and grab these credentials from Vault, right? But then the next thing they do is finally, log on with whatever client tool that they want to use, and then provide those credentials when it's asked when it's prompted of them to provide credentials, right? So more or less, 4 or 5 steps or so from a end user experience, a little cumbersome, and there are some security challenges as well with this whole process. Okay, so now let's take a look at how Boundary solves this, how Boundary makes it much easier for the end user, right? Again, we're trying to achieve more security, but without the cost of complexity. So let's take out the VPN and the jump host. Let's put in Boundary. So step number 1 is logging in. So very similar to a VPN, Boundary requires the user to log in. So we know this user's identity. We get some context around their profile and the roles they should have. So immediately with Boundary, we know the identity that's tied to this user, and Boundary enforces least privilege access, so that user can only access certain systems that have been authorized to them by the admin or by whoever controls the access to these systems, right? So great, from a security perspective, we're already better than a normal VPN. Now, the next thing the user does is, Boundary will present them with a list of systems that they are allowed to connect to, right? Again, least privilege access means they're only given a list of, systems they are able to connect to. They don't need to know the IP addresses at all. We're giving them just kind of, a human readable, recognizable name of systems that they can connect to. So they can use our desktop FAT client, or they can use the CLI client to be able to connect into one of the systems. So in this case, I have a desktop UI client where they just click the connect button to whichever system they want to connect to, right? So great. Behind the scenes, what happens is Boundary on the user's behalf will go out to Vault for them, and Boundary can grab those dynamic credentials rather than the user doing that themselves, right? So Boundary will grab the credentials and then present the credentials. In this case, it's a dynamic credential, so it's short-lived. It'll expire in a short period of time, so the risk is low of any type of exposure, right? So the credentials are given back to the end user, and then that third step is when the end user would use those credentials to log in to their system with the provided username, password, or SSH or whatever the case may be, right? So we've lowered the number of steps that's required compared to a traditional VPN jump host type of access. So now we've made it easier for the users to connect to their desired target resource, but how can we make this more secure? Well, Boundary has another feature called credential injection that automatically provides those SSH credentials to the target system on behalf of the end user. So when users initiate a session, credentials are not even seen by the user, eliminating the risk of credential exposure completely, right? So let's take a look at what that looks like now. So again, same thing, the end user logs onto Boundary. Once they've logged on, they select the system they want to connect to. In this case, again, the same Linux host. They click on that button, and again, Boundary will reach out to Vault, grab the necessary dynamic credentials, and then instead of giving it back to the end user, Boundary will inject it into that session for the end user, so that the user now is passwordless. They don't see it. They don't have a risk of sharing it or having it leaked or having it stolen on accident or on purpose or on accident, right? So that eliminates all risk whatsoever of credentials being leaked, because now Boundary is doing this on behalf of the end user. So basically, you've made it more secure, and we've also streamlined the whole process and reduced the steps even further of how a user can log into a specific resource. So great, right? You see how we gradually progress to make things easier and also more secure. But what else can we do? Well, what we've heard from many customers that have used other tools in their past lives, from other PAM vendors, a lot of times they've required them to learn new tools and use new processes, right? Very similar to them having to learn Boundary if they were to use Boundary. However, Boundary now has a feature called transparent sessions that is trying to make things even easier for those end users. Because even though with any vendor, right, even Boundary, we can make tools as simple as possible, but it still requires them to learn a new tool. They have to learn how to navigate it. They may have to learn the new commands. They may have to change their workflows. So this unnecessarily adds friction, which sort of reduces the overall adoption of said tool, right? Which means end users a lot of times end up finding workarounds that leads to potential shadow IT, and it introduces more risk to that organization. So now, like I mentioned, transparent sessions really aimed at addressing that, making it even easier and even potentially invisible to the end user, right? So that Boundary is not really needed to be, the end user doesn't really need to interact with Boundary at all. It's there to log in, but then that's all it should do, right? So let's kind of walk through that scenario again with this transparent session feature. It's in beta today, but it should be generally available very, very soon. So again, let's walk through that scenario. End user logs onto Boundary, right? Boundary enforces least privileged access, same thing as before. But then that's it, right? The user doesn't have to tell Boundary to connect me to something. All the user has to do is go to their favorite tool, right, the favorite client, to be able to then connect to that target system. So for example, if they're using SSH, they go to their terminal and type in SSH and the name of the host, right, or the alias that's given for this specific host. It could be PuTTY, it could be, you know, your RDP client. So whatever the protocol or the connection client tool that's used, you know, a database client as well, they would use that. And then what happens is, behind the scenes, again, Boundary will detect that. It'll grab credentials. In this case, it'll grab credentials for Vault, from Vault, dynamic credentials, and it'll also inject it into this Linux host. And the users connected, they're logged on, they didn't have to provide credentials. They didn't really have to interact with Boundary besides the login part, right? So you've seen how now it's more secure, but it's also extremely easy where the user didn't have to learn much about Boundary besides logging in. They can still use the client that I showed you, and they can run commands if they wanted to, but it's pretty minimal, if at all, right? So let's, I'll go into a quick demo so you can see all of this in action here. But before I do that, I do want to talk about, compliance a bit, right? Let's take this a step further and think about what organizations need in terms of compliance. You know, because the life cycle of a connection, it doesn't end when the session ends, right? The tracking and the system of record of sessions really continues on as far as the organization is concerned, because, you know, they have regulatory rules that they need to follow. So things like, you know, audit logs are required, but oftentimes they may not be enough. And so, you know, sometimes, you know, staying in compliance means that, you know, the organization needs to have records of, you know, granular action of everything an end user does within a session as well. So Boundary provides organizations with a way to standardize on this and record all SSH sessions, and also be able to play back all SSH sessions in the case of, you know, an audit happens, they have to meet those compliance requirements, or if a breach occurs, right, and they can go back and figure out exactly what happened, right? Okay, so now let's go into. Well, actually, before that, I have a demo to show you, but let's kind of summarize, because we talked about a lot of things, right? So let's kind of summarize all the things we kind of mentioned earlier, right? So from an end user perspective, right, when you're using Boundary, the experience is streamlined and it's seamless. The user can preserve their workflow and tools that they've always used, and this is, you know, consistent whether they're using, you know, AWS or Azure or GCP or on-premises private data centers, right? It's all the same. Boundary has no awareness of what cloud it's, you know, connecting users to. It doesn't really matter, right? From a compliance perspective, the organization has audit logs from Boundary, and also, you know, user activity with session recordings of all SSH sessions. From a security point of view, the SSH credentials can be injected directly into the sessions, so that this reduces the risk of exposure of, you know, of leaks, of sharing, of stolen credentials, right? Boundary will only provide access to authorized targets for each end user, so least privilege access is enforced. And lastly, the network is completely abstracted away from the end user, so the network's not exposed, and it's easy for the user. They don't have to know or track IP addresses, right? And then now let's quickly touch on some of the integrations with Boundary that work seamlessly in your organization's environment, because you've already invested in other tools, so we want to make sure that we work with them, right? So a lot of integrations work seamlessly. So Boundary works really well with existing identity providers like Okta, Entra ID, and Ping. So you can easily onboard and offboard new users or temporary contractors and easily give them access and then remove that access as well. So, you know, and then on top of that, providing things like single sign-on, right? Boundary provides native audit logging that, like I mentioned earlier, but it can also stream it to event management and event monitoring platforms like Datadog and CloudWatch. Session recordings are owned by you, so every playback can be played back because they've been recorded and stored into your preferred storage S3 storage vendor, right? So we support any S3 compliant storage vendor, whether that's on premises or in public cloud. As I mentioned earlier, you know, we can integrate with Vault. Boundary has its own storage internally to store static credentials, but you can integrate with Vault to get the power of a lot of those Vault's dynamic secrets engines to generate short-lived one-time credentials for each one of those sessions. Boundary's dynamic host catalog is a feature that offers native auto discovery of VM instances in AWS, Azure, and GCP. So what this does is that takes the burden off administrators from having to manually import or update the Boundary catalog of all the different VMs that you are allowing connections to, right? So instead of the users doing that or the admins doing that, Boundary goes out and automatically discovers and imports these VM instances from AWS, Azure, and GCP and brings it into Boundary's catalog. And any other resources that are outside of VMs, right? You can also use Terraform to discover and automatically import them into Boundary as well. And of course, if you want to manage boundaries, deploy Boundary and manage Boundaries lifecycle, you can use Terraform for that as well, just like you use Terraform for many of your other resources, right? Okay, so now let's get into a demo of the things I talked about, right? So I'm going to first start off with Vault and show some of the secrets engines that David showed you earlier. So if I go to secrets engines, I have a couple I'll show you. I have one that is a static secrets engine. So this is your most basic secrets engine, right? I go in and you store static username, passwords, or SSH keys. In this case, I have an example of an SSH key that I have stored onto this static secrets engine. However, as Dave mentioned, the better option and the more secure option is to go with a dynamic secrets engine. So I have a dynamic secrets engine to generate SSH certificates. So if I look in here, I have this secrets engine that will be used by Boundary, right? So if I go to Boundary here, I'll go to my AWS my project, and then I can click on credential stores, right? So within Boundary, I mentioned earlier, you can store credentials, locally into Boundary, directly into Boundary, or you can integrate it with Vault. So in this case, we have Vault as an example that points to my my Vault instance. So here's my Vault URL. It points to my Vault instance, and then it's also pointing to that secrets engine, the dynamic secrets engine on Vault as well. So if I go back to Vault, you'll see that matches the same name. So that means that we are leveraging Vault's secrets dynamic secrets engine. So for any one of my target hosts, let's say this Red Hat host, I will tell this, I will associate this Red Hat host with that same dynamic secrets engine. So when a user logs in, it'll automatically occur. So let's log in from an end user's perspective now, right? So this is the end-to-end user's point of view when they log in and they want to connect to something, and we're going to show off dynamic transparent sessions, right? We're also going to show off some of this, the fact that the user doesn't need to manage credentials at all. So we're going to log in. I'm going to use a simple username password. Single sign-on can work as well, but in this case, I'll log in with username password. Here's that list of targets that I, Betty, am allowed to connect to, right? At this point, I don't need to do anything here. I have this up just to so you can see the targets I'm connecting to. So let's use our the first example is to connect to an SSH or Linux host, right? A Red Hat host. So I have my Red Hat host. I'll bring up a terminal. And I'm just going to connect to it with this alias name, right? So this alias name could be anything. It could be, it could be an IP address. It could be, some human readable name. It could be URL, right? So I'm going to use that alias, and I'm just going to use whatever my SSH client and type in SSH and the alias name. And then as you can see, I'm logged on. Boundary connects me right away. Behind the scene, all this happened automatically. The credentials are grabbed from Vault and injected for me. So I log in. I don't have to know anything about credentials at all, and I can't share them or I can't leak them, right? So now I'm logged on. I'm just going to run a few commands just to show some activity as an end user. I'll create a file. I'll add some text in that file. And then we'll just go and we'll kill the session, right? So if I go to sessions, you'll see that I have this active session going on, and I can kill the session from here if I want. Now, from an admin point of view, if I go back to my admin UI, I can go to session recordings and I can see all the different sessions that have occurred or are still going on, and I can play them back. So if I go to view and I click play, I can see exactly what just happened 10 seconds ago from this end user who logged on, right? In this case, it's something, fairly, just writing a file, but it could be something nefarious, right? You can then see exactly what this end user did, and what commands it ran, what they downloaded, what they uploaded, what they did exactly for remediation, right? Okay, so now let's talk about Windows host, right? If I want to connect to a Windows host, what do? Right? Well, I can use any RDP client I want. So I have on my Mac, I have this RDP client, and the PC name basically is that alias name as well, right? So I just put in my Windows host, I add it to this client, and then I just double click on it to make that connection. And behind the scenes, Boundary is going to connect again, but this time Boundary is going to inform me that, hey, you have credentials here. So if I click on the notification, it'll take me to the client to tell me, here's my username, password for me to log on to onto this Windows host, right? So now I'm logged in, right, and I can do whatever I want, and from a RDP perspective, very simple as well, right? Streamlined, and I get a notification about it. What about other things, other type of targets like databases? So I have a Postgres database. I have a database client here called PG admin. So same thing. Let's connect to a database server. I'm going to give it a name, my Postgres database. And also, when you want to connect it, you give it the host name or the IP address. And same thing as before, on my Boundary, I'm going to grab the alias that's shown here on my Boundary clients, grab that alias, and that can be used as the host name, right? And then in terms of the credentials, I can also, if I click on connect, I can also get the username password as well. So multiple ways of doing this. So then I enter the password here and then click save. And once I click save, I'm connected into my database and I can start using it, right? So again, very similar to the previous interactions, except a little more interaction for the database point of view, but again, very simple, right? So now, what about web applications, right? So I have a private web app that I want only to be accessible within the network. So I grab the alias. In this case, it's URL. So I open up my browser, add that URL, and I'm connected. In this case, I have a private web server connecting over HTTPS to a picture of my name Taco, right? And to really drive the point home, if I logged off or signed off a Boundary here, I'll lose all connection, right? So we know it's secure because now I can't connect to my private web app. My database access is gone, right? You can see that no longer provides those charts. And if I go into my SSH client, try to connect, won't let me connect, right? I won't be able to connect it, right? And same thing with my Windows host. If I go back to that Windows host earlier, you'll see that, it's trying to reconnect, but it cannot, right? So again, showing that it is secure and it's only accessible if I'm logged on. If I do log back in, you'll automatically see that the connection gets restored, right? So as hopefully you can see, a few examples of how Boundary makes this a lot more secure by only allowing users to log in and connect to resources that they've been authorized to connect. So least privilege access. You saw the sessions being recorded for SSH sessions. You see the different types of connections for SSH where credentials are injected for you. You saw the Windows, you saw databases, you saw web browser or private web apps, right? So really driving that point home. We're trying to make it really simple and really easy, but also extremely secure. All right. So with that, let me go back here. So with that, we take it to, we're at the end here. We do have a lot of resources for you to go on and explore a little bit more if you don't know, if this is the first time you've heard of Vault and Boundary, right? We have great tutorials for you to get started on whichever level of expertise or experience that you have with Vault and Boundary and all of our products. Actually, we have certifications as well for those who wants to have that certification on and be an expert for a lot of our products. If this is new to you, you can sign up for free and try out a lot of our products. We have our HCP cloud platform where you can go in and deploy a lot of these and try them for free. And of course, you can also watch a bunch of videos on our YouTube channel. We have a lot of really great explainer videos. We have demo videos that are really short and consumable and really simple, so you can kind of easily understand even if you are new to a lot of our products. All right. So with that, I want to say thank you for joining us on behalf of David and myself. We are happy to answer any questions if there are any. Or looking forward to catching up with you at another time.
Hey, Van, thank you so much. That was wonderful. I'd love to see all the great demos. There's lots to absorb, lots of new capabilities, and really appreciate getting a chance to see that firsthand. If anyone does have a question, please go ahead. There's still time to drop it in the chat here, and we can have David and Van address that. Or if you think of something over the next hour or so and you want to come and ask a question on office hours, that's taking place today at 2:30 p.m. Eastern, and you'll be able to just ask your questions there. Also, this session is recorded. All the sessions are recorded, so you can go back to any of them. But if you're thinking about, hey, I wonder, remembering part of the demo and you want to go back and see it again, you can always go in and rewatch this and then reach out with any questions you might have. Really appreciate all this great detail that you put together, David and Ben. So just give it 1 second to see if there's any questions. I don't see any coming in, but there is going to be a poll that pops up in the lower left section of your screen. So make sure you take a moment to provide us feedback. We want to continue to make TechCon better each year. So we want to hear from you, see what you think. And we have 1 more sessions left. So we are down to the final presentations that will be going on at 1:25. So go ahead and grab a coffee and then come back. And if you're coming back to this infrastructure automation and security track, we have a different topic. We had an emergency with our business partner speaker, so we are going to have one of our AI ops and cybersecurity experts come and talk to you about AI ops and security. So just to note that that was a different topic changed in today. So it's March Madness. You got to be agile and move with all the different things happening. So just to let you know, we did have a change there. So I appreciate everyone's time, and we look forward to seeing you again.